Hello everyone, in this video we'll discuss a numerical on power and effort of governor. And we have taken the case of a Hartnell governor, which is a spring-loaded centrifugal type of governor. Now we are given in the question the radius of rotation of balls, which is 60 mm. Minimum speed is given 240 rpm. Length of ball arm, which is small a, it is 130 mm, and sleeve arm, which is small b, that is given 80 mm. Small m, which is mass of ball, 3 kg, and capital M, which is the mass of sleeve, is given as 5 kg. Spring stiffness, small s, is given 20 Newton per mm. We have to find the speed when sleeve is lifted by 45 mm, initial compression, governor effort, and the power. Okay, so we have written all the data given: A, B, H, R1, small m, mass of the ball, mass of the sleeve, N1, S. So because I know N1, I can easily calculate omega 1, which is 2 pi N1 upon 60. And because we know R1 and omega 1, we can calculate F1, which is M R1 omega 1 square. Right? Now what I want to calculate is R2. With the help of this diagram, we can see that CA, this is this is the length of the upper arm which holds the ball, and AB is the length of the arm which is connected to the roller, that is inside the groove of the spindle, right? So we know that theta for, because this bell crank lever is at 90 degrees, so these angles are same. This is also theta and this is also theta. This is theta, right? So theta is what in this triangle, if you see, it is R2 minus R1. That means this value upon A. And in this triangle, if we see theta, it is H upon B. So when we equate these two things, we get the value of R2 because we already know R1, A and B and H. So we put the value of R2 from here in this equation, right? So all the values are known, and we can calculate the value of F2, which comes out to 409.7 Newton. Now this is the centrifugal force. So this is equal to mR2 omega 2 square, right? So we know the value of R2, we know the value of M, we can calculate N2, which comes out to 325.5 rpm. Now we also know that if we take the moments about this point A, and because there is no obliquity in the system, so mR1 omega 1 square A is equal to half of mg plus spring force, which is Fs1 into B. When you put all the known values, we get the initial compression. For initial compression, we need Fs1 and S. S is already known. So spring force Fs1 we can get from here. You put the values and you get the value of initial compression. Right? Now for effort is S, that is the spring stiffness, because the spring is in pre-compressed condition, into the height upon 2. Right? So you put the values, we already know the spring stiffness, that is 20,000 Newton per meter. H we are already given this value, it is 0.05 upon 2. That is basically the displacement of the sleeve, and we get the value of effort as 500 Newton. Power is what? Effort into displacement. We know effort, which is 500 Newton, and displacement. This displacement is 0.05 meter. So when we put the value, we get power as 25 Newton meter. Thank you.